In this video, we're going to evaluate the integral of tangent to the fourth of 2x. So it's a trig integral, and I'm going to break this up as tangent to the fourth. I'm going to break it up as tangent squared of 2x times tangent squared of 2x. So I've got then tangent squared of 2x, and then I'm going to replace the other tangent squared by secant squared of 2x minus 1. That's one of your identities. 1 plus tangent squared of an angle is equal to secant squared of the same angle. So we solve that fundamental identity for tangent squared. We get secant squared. So this is secant squared of 2x minus 1. Then I'm going to multiply through there. This will be tangent squared of 2x. And that multiplies the secant squared of 2x. And that's your minus tangent squared of 2x. And what I'll do is I'm going to break this up into two integrals. So this will be one integral here, tangent squared of 2x times secant squared of 2x. And then I'll have another one here, minus tangent squared of 2x dx here. And I've got a dx here somewhere. And then again, I'm going to use the same identity here. Tangent squared of 2x can be replaced by secant squared of 2x minus 1. So for the first integral, I'm going to let u equal to tangent of x. Or I should say tangent of 2x. So du would equal to the derivative tangent is secant squared of 2x. And then we multiply then using the chain rule, multiply by the derivative of 2x, it would be 2. You put the 2 right here, but I'm going to divide by 2, so this will come over here. So I've got this. So then this would equal, I'm doing one integral at a time here, okay? So for this one here, this is going to be the u. Tangent is u, so this will be u squared here. And then secant squared of 2x dx, that'll be the du over 2. I'll put the 1/2 out in front. And then this would be your du. Then we just integrate with respect to u. So add a 1 to this, it can be a 3, and then divide by 3. So that'll make this 1/2 times a 1/3 is going to be 1/6. And then this will be u to the third over 3, u to the third here. Again, in the 1/2, the 1/3 I already multiplied the 1/2. But u is tangent. So I'm going to put u to the third here, and then the 3 is over here. But I'm just going to write it this way. Again, when I integrated this, I got u to the third over 3, and I multiplied the 3, the 1/3 times the 1/2, I got the 1/6. And instead of putting u to the third here, we know that u is equal to tangent of 2x. Let's just write it like this. And then I could put this in parentheses, or I could put the 3 right here. I'll go ahead and put it like this. Again, I could put it right in here between the n and the 2. But there you have it. And then for this one over here, replace the tangent squared of 2x by secant squared of x minus 1, and we can integrate this one right away. So the minus comes out of here, and the integral of secant squared is tangent of the angle, and the angle is 2x. So I have it like this. And then again, the chain rule in reverse here, derivative of 2x is 2. So that puts the 2 here. And then what do I have? I have a minus and a minus 1 here. This is distributed, so it's plus 1. Integral with respect to x, that's just going to be plus x. And then it's the constant of integration, which is c. Trig integral, evaluate it, and again the results are 1/6 times this. I could put the 6 under this if I wanted to, but I'll leave it this way. 1/6 times the tangent of 2x, quantity to the 3rd power, minus tangent. Again, we could put parentheses here to make it more clear. Or over here, minus tangent of 2x over 2 plus x, and then it's plus the constant of integration. Thanks for watching. We'll see you next time.